Hello students, in an experiment to study the spread of soil disease, the area of 10 meters square of soil was exposed to an infection. In a simple model, it is assumed that the infected area's growth at the rate which is proportional to the product of infected area and uninfected area. Initially, 5 meters square was infected at the rate growth of infected area was 0.1 meter per day. So if I assume, then for the first part of the question, we have to write dA over dt is directly proportional to the product of infected and uninfected area. So that means if I removed the proportionality sign, so I could write dA over dt is equal to K into A into 10 minus A. So that's the thing they have asked to express it as. So K is the proportionality constant, and we know that the dA dt value is 0.1, and initially the area affected was 5. So that means this is into 5 and into 5. So we got the value of K as 0.1 over 25, which is nothing but 0.004. So if I put that value in the equation, so our equation becomes dA over dt is equals to 0.004 into A into 10 minus A. So that's the answer for the first part of the question. Now moving on to the second part of the question, they have asked us, by expressing this into the partial fraction, we have to solve the differential equation. So to express the function as 1 and 10 minus A into partial fractions, we can write it as A over A plus B over 10 minus A. So if I simply take up the LCM and compare the numerator, so I got it as 1 equals to A into 10 minus A plus B into A. If I put the value of A equals to 0, because then in that case B vanishes. So I got 10A equals to 1, or the value of A that we got is 1 over 10. Simply, if I put the value of A as 10 over here, so that means in this equation, so that means if A vanishes, so I got again 10B equals to 1, or the value of B is again 1 over 10. So that means our partial fraction of this form can be expressed as 10 by A plus 10 over 10 minus A. So that will be the partial fraction form, and that's the first part of the question. Now they have said solve this differential equation obtaining T in terms of A. Now to do that, that means we have to use the differential equation which is written over here. So that means we can write dA over dt is equals to 0.004 A into 10 minus A. So by using separation of variables, we can write dA over A into 10 minus A, and that's the integration, and that's equals to 0.004 into dt. So if I integrate both the sides, so we can use the partial fraction results that we obtained in the first part of this question. So that means it becomes 10 by A dA and plus 10 by 10 minus A dA, and we are integrating it from both the sides, and that becomes 0.004 T. So the integration result, this should be ln A, and this should be minus of ln 10 minus A, and that is equals to 0.004 T. So we know that at T equals to 0, A equals to 5. So we'll put the result. So this is plus C. So we know that at T equals to 0, A equals to 5. So if I place that result over here, so I got it as ln 5 minus of ln 5, and that is equals to C. So the value of C is 0 that we got. So if I place that value of C as 0 over here, so the equation becomes ln A over 10 minus A is equals to T over 25. So we can express T equals to 25 ln A over 10 minus A, and that will be the final answer to this particular question. Thank you, students.